Today's problem of the day. Form a palindrome. Given a string, find the minimum number of characters to be inserted to convert it into a palindrome. For example, if we are given the string AB, then the number of insertion required is just one. We can either insert a B here, okay, it becomes BAB, it's a palindrome, or we can either insert a here, which becomes another palindrome ABA. So only one insertion required at that position, at that point. Now the next string is AA. AA is already a palindrome, so we don't want to insert any other characters in order to make it palindrome, since it's already palindrome. So if it is already palindrome, then we have to return 0, as no insertions are required. If it's ABCD, then we need to make 3 insertions. We can either insert like CBA to the very end, or we can insert DCB to the very front. So so that's the first input, and for the second input it's already given a ABA. So so what's actually a palindrome? It's simple, like everyone know. If we are having ABC BA, or if we have ABBA, both of these cases, let's look from the front and let's look from the back. And if we are able to read the same string from left and right, and we get the same string, then that means it's a palindrome. So here itself, like it can be deduced, or we can prove that a given string is palindrome by making use of a 2-pointer approach. We can keep a pointer here, we can keep a pointer here, so these two are equal, so we move both of a pointer here and here, so these two are equal, and we didn't care about this one because we will be running our loop until the if I is the pointers, I and j are the 2 pointers, we will be running the pointer until I is less than j. Now same way with this one, we keep one pointer here, we keep one pointer here, but if both of them are equal, we keep here, we keep here, both of them are equal. And suppose we are having some other characters, other string, same way we keep 2 pointers here, we keep 2 pointer here, these two are equal. Okay, now we move pointer here, we move pointer here, but this is B and C, this is not equal, so in this case we will be returning false. So this is just a basic for palindrome. And in order to tackle this problem, the idea that we will be applying is longest common subsequence. And longest common subsequence between which of the string? Of course it will be one of our string, say it's ABCD, and which is the other string that we need to consider. The other string, like one thing that we can note is, like we can either have DCBA here, okay, or we can have DBA here. So in either of these cases, like this is a palindrome or this is a palindrome. So if we reverse the given string, and okay, we are reversing the given string, and if we find longest common subsequence of, suppose this is S1 and this is S2, okay, and if we find the longest common subsequence of S1 and S2, and we get some value, say y, and let this be the length of the given string x, then the number of insertion that we required will be x minus y. So it's first of all a basic check. If our s is equal to null, or s dot length is less than or equal to 1, we have a null string, or we have a string of length 1, and that will be already palindrome, so we don't want any insertion, return 0. If our string is already a palindrome, so if is palindrome of s, if it is already palindrome, then also we don't want any what do you say, we don't want any insertion. Now what we thought, we will be finding the LCS of this string and the reverse string, so we need the reverse. Reversed s is equal to find reverse of s. So these are helper functions. This is palindrome is a helper function. This find reverse is a helper function that we will be implementing soon. Now our final answer will be, let's have the length, say int length is equal to s dot length. And we can also pass this length here, length. Okay, so we just find the length minus longest common subsequence of s comma reversed s comma length. Both of them will be having the same length. So okay, so now let's start with the first is palindrome, a general algorithm for checking whether a string is palindrome or not. So we can have a pointer which is pointing to 0. We can also have another pointer which is get up the very last index. Now while I is less than j, okay, if s dot caret of I is not equal to s dot caret of j, this is the terminating condition, the quick termination. Like if the two characters are not equal, we don't want to further explore inner and inner. If we see at the very starting itself, we can just return false. Otherwise we keep on moving our pointers I to the forward, j to the backward, and if we successfully exit out of this loop, then it's a palindrome, so we return true. So we are done with this palindrome. Now we need to do the find reverse. So that's also pretty straightforward, and it is always good to break down the logic into different functions. So let's make use of a string builder, new string builder, and we need to traverse the string from the back, so we can easily make it. For int I is equal to length minus 1, I greater than equal to 0, I minus minus sb dot append of s dot caret of I. Now just return sb dot to string. Now the two symbol logic is palindrome, find reverse is also done. Next one is also a classic problem. You can find this problem in Geeks for Geeks itself. So pretty straight, a classic problem on DP. So int longest common subsequence, we are having string s1, string s2, int length. I'm not going the code walkthrough for the longest common subsequence, this DP table and all. I'm just directly implementing for the DP solution. So our idea is simple, like if it is already palindrome, we return 0. Otherwise we just find the reverse of the given string, and our result will be the length of the given string minus the longest common subsequence between the given input and the reverse string that we found. Okay, so we create the DP table. It will be of the length plus 1, length plus 1. Here both s1 and s2 will be of same length, because one is the normal string and the other one is the reversed of that normal string. So in this case, like I am taking the length as same, otherwise it will be like s1 dot length plus 1, s2 dot length plus 1. Every time like this, length will not be equal in general case, but for our case, for this problem, like the lengths are equal for the both of the string, so we just took like this. Now for int I is equal to 0, I less than or equal to length I plus plus. For int j is equal to 0, j less than or equal to length j plus plus. If I is equal to 0 or j is equal to 0, we set our DP table as 0. Else if both the characters are equal, if s1 dot caret of I minus 1 is equal to s2 dot caret of j minus 1, that means we found a common subsequence, so we update it. We update our table. It will be minus 1 j minus 1 plus 1. Else we need to take the maximum from the table. From the table it will be from the either from the top or from the left. So dp of ij is equal to dp of I minus 1 j comma dp of I j minus 1. Okay, and we need the max between this. Mat dot max of dp of I minus 1 j or dp of I j minus 1. Now at the very end of the table we will be having the longest common subsequence. So while discussing about the time complexity, let's look each of the methods. So is palindrome we are going through the string once. Okay, we are making use of 2 pointers and it can go through the whole string. Okay, so it will be big of n in the worst case. Now for the find reverse, it's also like we are just traversing from the back to the front. So here also the time complexity will be big of n where n is the length of the string. Here also big of n where n is the length of the string. And if we take space for this creation of the string builder, like we are having an extra space big of n here. If we do not consider, like we are having a big of 1 space. Now for our longest common subsequence, we are making use of 2 loop. One loop while one loop goes from I is equal to 0 to the length, the other loop also goes from j is equal to 0 to the length. So this part, the time complexity will be big of n square. And we are also making use of a 2D dp table which is of size length plus 1, length plus 1. So the space complexity will be also big of n square. So the overall time complexity will be big of n square. The overall space complexity will be big of n square. Now let's see. Yeah, 3 a b d must be 2 and it's 2 and we are submitting. And we are passed. Okay, so that's the problem. Just check if it is a palindrome. If it is a palindrome, return 0. Then find the reverse part of the given string. Then calculate the longest common subsequence between the given string and its reversed part. Then our final result will be the total length of the given string minus the longest common subsequence between the given string and the reverse string, which results in a time complexity, overall time complexity of big of n square and overall space complexity of big of n square. So that's our problem of the day for my palindrome.